Hello friends, today I am going to talk to you about the theories of failure. In our strength of material course, we were taught that if stress exceeds a limit, the structure will fail. Then why these theories of failure are required? Now let us consider a mild steel rod of yield strength 250 megapascals and we are considering yielding as failure. Now, yielding is considered as failure in most of the applications where most of the engineering applications where metals are used. So this is the stress state. As you can see in the diagram, there is a unidirectional tensile stress of 200 MPa. Now, since the induced stress, that is 200 MPa, is less than the yield strength of 250 MPa, the structure is safe from yielding. Now, let us make it a little bit more interesting. Have a look at this diagram. Let us consider a mild steel plate under lateral pressure having a yield strength of 250 MPa, and again, of course, we are considering yielding as failure. So you can look at the stress state here. So in one direction, we have a stress of 200 MPa, and in another direction, we have a stress of 220 MPa. Now, this can cause a dilemma. For example, 200 MPa and 220 MPa individually, they are each of them are less than this 250 MPa. But there are two stresses, right? So if we add it up, 200 plus 220 is 420 MPa, which is more than 250 MPa. So will it cause failure, or do we just have to take the least of this or the most of this, which is 220 MPa, and uh, but and consider and compare it against the yield strength, or uh, shall we take something like square root of sum of squares, like what we take for forces? uh, F resultant is equal to root of fx square plus fy square plus fz square, right? Shall we do something like that? So no, we have a dilemma like that. So how do we solve it? For that, we are having theories of failure. So in this particular case, we have to see the von Mises stress, because the von Mises stress theory has been found to be the most successful theory in predicting the yield stress of ductile materials. And here the von Mises stress is 210 MPa. Since the induced von Mises stress, that is 210 MPa, is less than the yield strength, the structure is safe. Now let us make it a little bit more interesting. Let us consider a brittle structure. So same, instead of a mild steel rod, we are having a cast iron rod. It has an ultimate stress of 300 MPa. While for the mild steel rod, which was a brittle material, we considered yielding as failure. Here we are considering cracking as failure. So now let us do a small analysis of this. So the stress induced is 200 MPa, but the ultimate strength is 300 MPa. Since the induced stress is less than the ultimate strength, the stress is the structure is safe from cracking. Now we'll make it a little bit more interesting for the brittle material also. Let us consider a simply supported plate of cast iron under lateral pressure of ultimate stress 300 MPa, and here also we are considering cracking as failure. So here you are having bidirectional stresses. So there is 200 MPa in one direction and 220 MPa in the other direction. So we have dilemmas similar to what we had for the mild steel plate. But now the question is, can we use von Mises stress for for this brittle material? The answer is no. The most successful theory for predicting the cracking of brittle materials is the maximum principal stress theory. Now here the maximum principal stress is 220 MPa, which is less than the ultimate strength of 300 MPa. So that means the structure is safe. So these are the final comments I'm going to make. There are six failure theories for isotropic materials in the literature, but only two are popular in the industry. One is the von Mises stress theory for predicting yielding of ductile materials, and the principal stress theory for predicting the cracking of brittle materials. The theories of failure are used to evaluate the possibility of failure due to 3D stresses using 1D properties like stress strain diagram. So we test in 1D and we use the 1D properties to predict failure in 3D. That is why the theories of failure are required. Thank you, friends.